Hey there, this is Mr. Alexander, and today I want to talk about transformations of the absolute value parent function. And if you've forgotten, the parent function for absolute value is f of x equals absolute value of x. So here we're given some graphs, and it says write the equation that models each given graph. So they're all going to be in the form of the absolute value of x. And we're just going to do some transformations. So I'm just going to pick a couple of these randomly. I'm looking at number 5. That one looks interesting. And what I like to do is I like to kind of list out the transformation that's occurred. So this one looks like it's gone left 2. So I'm going to make myself a little note. Left 2 and up 1, 2, 3. I know it's not exactly on 3. I'm going to go ahead and assume that's up 3 though. The question is there anything else? Yeah, I think so. I think this thing's a reflection. It's going downwards instead of upwards. This thing's a reflection. And the other thing that's going on here is I need to check the slope of these lines. Is it up 1, down 1, over 1? What's going on here? And it looks like this thing is going down 1, 2, 3, 4 over 1, 2. So it looks like the slope is down 4 over 2, which is a slope of 2. So I'm going to say that's a vertical stretch of 2. So with that information, we can go ahead and write this equation. I'm going to start with the y equals, or f of x equals. It's up to you. And I know it's a reflection, so I know it's going to be a negative right there. I also know that there's a vertical stretch by a factor of 2, so I'm going to write a little 2 right there. Make my absolute value bars, and I'm going to put my x in there. And I know this thing is going left 2. Now inside these bars, that's counterintuitive, so that's going to be a minus 2 right in there. Sorry, plus 2. Left 2 is plus, it's counterintuitive. And then up 3, that's up outside, that's plus 3, just like that. That was kind of quick, but let's do another one. I want to make sure we talk about a few of these. So I'm looking at number 8, and it's the same process. It's been shifted right 3, up 2, and then it's a reflection. And I'm going to look at the slope now. So this thing's at 2, and it looks like it goes down 1, 2, 3 over 1. So I think this thing is a vertical stretch by a factor of 3. So when I write the equation, I'm going to write f of x, or y, equals, reflection is negative. It's been multiplied by 3, so I'm going to put a 3 in front. I'm going to have my absolute value bars, and it's going to be x. So we went right 3, so that's going to be minus 3 inside the bars, and then up 2, so that's plus 2. Let's do one more. Let's go back to the top. Let's look at number 2. Do all of the ones in the middle there. So this one is definitely a reflection. It's upside down. It's been shifted from the origin left 1 and up 2. And let's look at the slope. So right here, that's negative 1, 0. It looks like it goes down 1 over 1. So actually, this thing doesn't have a vertical stretch or a vertical compression. So I don't need to write that times 1 because the slope is the same as the parent function. So when I write it, I'm going to write y equals negative for the reflection. I don't have to write the 1 in front because there hasn't been a vertical stretch or compression. The absolute value bars, x, it went left 1, so that's counterintuitive, so that's plus 1, and up 2, so that's plus 2. So those are 3 of them. I'm going to turn over to the second page now, since we talked about 3 of those, which is plenty. And I think these are all pretty simple. The ones I want to talk about, maybe the graphing ones. Determine the equation, state the domain, and range. Let's just talk about a few of these. So I'm thinking maybe some of the harder ones. So if we're going to write an equation, then what we need to do, the first thing we want to do is just identify the transformations. I count 1, 2, 3 transformations on this thing. The first one, that's a vertical stretch. It's by a factor of 2, so you can write times 2. You could just write vertical stretch. Either way, it's fine. 2, I see that plus 4 there. That means this thing's going to go left 4 units from the origin. Left 4. And the third thing is this minus 5, which means I'm going to push it down 5 units from the origin. So the first thing you ought to do is start at 0, 0, because that's where the parent function starts, is at 0, 0. Go left 4, down 5. So right there. And to draw this thing, we've got a vertical stretch of 2. So we're going to go up 2 over 1 in both directions. Up 2 over 1 in both directions. And you can make as many dots as you want, or you could just make a straight edge, use a straight edge, to fill in the rest of it. And right there. I'm going to try and make these as straight as possible. Don't forget to put some arrows at the end there. And that's your absolute value function. That's that thing graphed. Let's do a couple more like that. We've been talking about a lot of vertical stretches, maybe not so many vertical compressions. So let's talk about that. Vertical compression here. I count 1, 2, 3, 4 transformations here. So let's go ahead and list them. 1, that negative, that's a reflection. 2, the 1/2, that's a vertical compression by a factor of 1/2. The third thing that's going on here is that plus 2. That's going to make this thing go left 2 units from the origin. And the plus 6, that's going to make this thing go up 6 units from the origin. So let's start from 0, 0 and go left 2, up 6. I'm going to put a dot right there. Now this thing is a reflection, so I know I'm going to go down. It's going to be facing downward. And what I'm going to do is I see that the vertical compression is 1/2. That's basically my slope. What that's telling me is I need to go down 1 over 2, down 1 over 2, down 1 over 2 in both directions. So this thing's a little bit flatter than the last one that we did. It's been compressed. You can just extend this thing as far as you want. But make sure that at the end, you put some arrows at the end, because this thing goes out forever in both directions. Now what I skipped on both of these, because I want to talk about them at the same time, is the domain and range. So I'm just going to put a spot for D and R for domain and range on both of these. Now when I think about domain and range, I'm thinking how far left, how far right, how low to how high. Now the domain of this thing right here, it goes left forever and right forever. So there's 2 ways to write that for now. There's actually about 4 different ways to write it, but you can write it as all real numbers, which is this fancy italicized R, capitalized italicized R. But I kind of prefer to use inequalities. So on this one, another way to say that is from negative infinity less than x less than positive infinity. Now these are less than symbols because we don't actually touch at, infinity in either direction. If it touches the point, then it's less than or equal to, which becomes the case in the range. The range is how low to how high. The lowest y value on here is -5. And it actually touches -5, so that means that the y is between -5 and how high does it go? Infinity. It's between -5 and infinity, where it touches -5, but it doesn't touch infinity. Now the nice thing about absolute value functions is that the domain is always the same. it's always negative infinity, sorry, to positive infinity. That's never going to change for the domain of absolute value. It's the range that's going to be different every time. So ask yourself the question, how low does this thing go? This thing's going down forever. It's going to a negative infinity. And I'm going to say that's less than y because it doesn't ever touch negative infinity. But how high does it go? Well, it actually touches the y value of 6. So it's less than or equal to 6. So depending on if it opens upwards or downwards, that will affect the domain, not the domain, but the range. And I think that's all the help you need to be successful on the rest of these. So thank you for watching, and we'll see you in class.